Hi, I got your email and I decided to tape because it's easy for me instead of trying to reply through email. So you have, oops, wait a second. Wait a minute. By the way, I don't have my pen here, so I have to type to use the clicker, not the clicker, the buttons, the keyboard, and it's going to be not as efficient as if I had my Wacom, but I don't have a Wacom now. So this is what you got. If the velocity is above the just right velocity, when you get to this point, here's your gravity force, and you have your normal force. When you do your Newton's law thing, normal force plus gravity equals mv squared over r. Okay. So the sum of these two forces is your centripetal force. So the enunciator mentioned a just right velocity that allows the car just pass by. And when this happens, the normal force is zero. So the velocity is referring to is one that mv squared over r is equal fg. So these two quantities are the same, meaning your normal force is not there anymore. If you were in the car and the car was moving with the just right velocity at the highest point, you wouldn't feel the seat. You would feel as if you were weightless. So you got to the highest point, you feel, like, oh Lord, lightheaded, it's just floating air. Because the normal force that I'm feeling now because I'm sitting in a chair, you might be sitting in a chair, so you feel the chair on your, rear end, um, as I'm feeling right now. So this normal force, we feel if we are in the car, if we are with a speed bigger than the just right speed, because we are pushed against the seat, and then the seat reacts, and then we feel that. Okay. Now, if the velocity is just right, we feel weightless. We don't feel the belt, we don't feel the seat, we are just floating air. So what happens if the velocity is less than that just right velocity, right? The fact that just right velocity is square root of r g over m. Do your calculations and you can find. So if the velocity is less than square root of rg over m, what's going to happen? Well, you're going to go down in your loop-to-loop, and when you get to this highest point, you're going to fall in a projectile motion, which means the normal force now is zero, but you don't make the curve. Gravity pulls you down, and now you have a projectile motion with the gravity pulling you down, basically. Okay? So you don't stay there. Now, the problem mentioned that the wheels are attached to the track. So what does it mean? So here are the wheels on the top. Right? So this is the track. The track. Of course, we have some fulcrums here, something. That's the track. And then you have a mechanism with a little wheel right here. I think that's how it goes. And then it comes out and then bends around. And this thing attached to a wheel is right here. That's the wheel of the cars. The little thing. Of course, the wheel is kind of a metallic, I think. And this goes in there, right? So what happens when you are in the highest point? If the velocity is less, the wheel and the car should all fall down. But it doesn't because you have this safety mechanism here, which means at that moment, the normal force is from the track to this mechanism. that holds it in place. So you gotta have a heck of a metal here, right? Because this metal should be able to withstand this normal reaction and the weight of your truck, car, not weight of the truck, the weight of the car. So if you are in that situation and the speed is less, so as it happened in one amusement park, I don't remember which one, it got to the highest point. There was a lady with a son, and the lady was heavy weighted, was overweighted. Um, the car stopped. Of course, what would hold her in place? The seat belt. But she was not wearing, and I think she was overweighted. And when she entered the car, she didn't buckle herself completely, and the person in charge of checking didn't check. So when she got, and one of these fatalities, right, coincidence that was fatal, she got up in the top part, the car stopped, and and the belt didn't hold her on, and then she fell. She plunged down, and the son was next to her. So it's a tragic story. So it doesn't fall. We don't. If we are in that situation, why we don't fall? Because of the belt. The belt hold us in place, and the belt is attached to the car. Why the car doesn't fall? Because this mechanism here is attached to the track, and then that's why it doesn't fall. Does it make sense now?